Good day, everyone. Today's topic is Introduction to Machine Learning. In that, characteristics of machine learning models. So, what is machine learning models? A machine learning model is a computational program that learns patterns from data and makes decisions or predictions on new or unseen data. It is created by training a machine learning algorithm on a data set and optimizing it to minimize errors. Key characteristics of ML models are finds hidden patterns from historical information, can forecast values or classify inputs, learns from additional data and feedback, and reduces human effort and increases efficiency. Machine learning model pipelines. Those are machine learning models. It starts from problem statement. What kind of problem statement you have chosen, and you want to solve it using the machine learning models. And next is data collection for the same. And once the data is collected, the raw data is collected or from the data set. Next, we have to do a pre-processing. Once data pre-processing is done, next it goes to the select algorithms, and next it goes to the training, where with the collected data using the algorithm. You will be training the model and you will be evaluating the model as well. And evaluating the model and the algorithm as well. If accuracy is less, again the process will be repeated from select algorithm, training, and evaluate. And once it achieves the optimal level of, or the expected output, then we stop the process. Next is like components of machine learning model. To build an effective machine learning model, it is important to understand its core components. These elements define how a model learns and predicts and improves over time. And parameters, internal values learned automatically during training that define model knowledge, and predictions like weights and biases in neural networks. So hyperparameter or other components of hyperparameters like external configuration settings defined before training that control learning speed, complexity, and model structures. It can include learning rate, number of epochs, batch sizes, etc. And loss functions like mathematical functions that measures how far predictions are from actual outputs and guides model training. It can be MSE for regression and gross entropy for classification, and optimization algorithms that adjust parameters iteratively to minimize loss and improve model accuracy and convergence like gradient descent and Adam RMS prop, etc. And evaluation metrics or quantitative measures to assess model performance on unseen data and enabling comparison and selection. Some examples are accuracy, precision, recall, FN score, RMSE, R squared score, etc. And types of machine learning models. Machine learning models can be broadly categorized into four primary paradigms based on the nature of data and the learning objectives. So, one is supervised learning models. In supervised learning models learn from the labeled data where each input has a known output. The goal is to map input features to the correct target value using a mathematical models. Regression models predicts continuous numerical values rather than categories. Some of its algorithm or linear regression fits a linear equation to predict numerical outputs, and polynomial regressions like extends linear regression by fitting polynomial relationships. Decision tree regression uses tree structure to predict continuous values, and random forest regression ensemble of decision tree regressions for better prediction, and support vector regression SVR use SVM principles for regression tasks, and classification models assign input data to predefined categories. Some of its algorithms are logistic regression predicts the probability of categorical outcome using a logistic function, Support vector machine like SVM finds the optimal hyperplane to separate classes with maximum margin, and decision tree speaks data recursively based on features to classify samples efficiently, and random forest combines multiple decision trees to improve accuracy and reduce overfitting. Name bases like user probability theory, assuming features independence to classify data. K nearest neighbor KNM classifies based on the majority labels of the nearest neighbors, and gradient boosting or XG boost like GBM, like ensemble methods that sequentially combine weak learners to improve performance. And unsupervised learning models are like these models are like unsupervised learning models work with the unlabeled data, discovering hidden patterns, clusters, or structures without predefined outputs. Clustering groups similar data points into cluster based on feature similarity. Some of its algorithms or k-means divides data into k-cluster using centroids. DBScan detects dense clusters and identifies outliers automatically. Hierarchical Hierarchical clustering builds a nested tree structure of cluster based on similarity. Dimensionality reduction reduce high dimensional data while retaining important information of analysis of or visualization. Some of its algorithms techniques are PCA, principal component analysis, project data into principal components to reduce dimensions. LDA, linear discriminant analysis, maximizes class separability while reducing dimensionality. Anomaly detections like identifiers or rare identifies rare or unusual patterns in datasets that deviate from the normal behavior. So, like isolation forest or the algorithms or methods, models use detects anomalies by isolating data points that occurs fewer speaks in the random tree structure, local outlier factor LOF flags anomalies by comparing the local density of a point with the densities of its neighbors. Associations discovers relationships or co-occurrence patterns between items in large datasets, and a priori finds frequent item sets and builds association rules using support and confidence. FP growth uses a compressed FPT structure to mine frequent patterns faster. ECLAT uses set intersections to identify frequent item sets efficiently. Next is semi-supervised learning models. Like these models, semi-supervised learning models, use a small amount of labeled data combined with a large amount of unlabeled data to improve learning when labeling is expensive or time-consuming. Generative SSL like creates synthetic labeled samples of for training. And next is reinforcement learning models. Reinforcement learning models learn by trial and error interactions with an environment receiving feedback in the form of rewards or penalties. Value-based learnings like learns the expected rewards of actions to select optimal choices. Like G-learning updates action values using a Q table to learn optimal policies. In this reinforcement learning, we also use deep Q network, DQN, uses neural networks to approximate Q values for large state spaces. Policy-based learning learns a policy directly to choose actions that maximize rewards. Policy gradient optimizes action selection probabilities directly using gradient ascent. PPO, proximal policy optimization, improves policy gradients with stable updates and clipping. Actor critic combines policy learning actor and value estimation critic for efficient training. And model-based oral, like learn a model of the environment to simulate and plan actions. Here we use Monte Carlo tree search (MCTS), uses tree-based search with simulations to choose optimal actions. Deep learning models or Deep learning is a subset of machine learning that uses artificial neural networks with multiple layers to automatically learn complex representations from data. Deep learning models excel at handling large datasets, high dimensional inputs, and tasks requiring hierarchical feature extractions. And common deep learning models are ANN, artificial neural network, basic basic neural networks for general predictions and classification tasks, and CNN's convolution neural networks extract spatial features for image processing, object detection, and face recognition, and RNN's recurrent neural networks process sequential data by maintaining memory of previous inputs used for text and speech, LSTM's long short-term memory, advanced RNNs that capture long-term dependencies in sequences for language modeling and time series predictions, and also GRUs, gated recurrent units. It is a simplified ordinance that handle long-term dependencies using reset and update gates requiring fewer parameters than LSTMs. Sequence to sequence, set to set, that is sequence to sequence models, convert one sequence into another, commonly used in machine translation, text summarization, and conversational AI. And autoencoders learn compressed representation of data and reconstruct the original input used for noise removal, dimensionality reduction, and anomaly detection. Transformers use self-attention to model relationships in sequential data, widely used in NLP tasks like ChatGPT, BERT, and machine translations. And GAN, so generative adversarial networks generative, generate realistic synthetic images, videos, or data by pitting a generator against a distributed. Differences between ML algorithms, ML model, and so difference here we compare ML algorithms, ML models, and ML training. So ML algorithm. So what is the ML algorithm? It is mathematical procedure or a recipe used to learn pattern from the data. An example is like linear regression algorithm, Bayesian tree algorithm. ML models the final learned function created after the algorithm processes data used for predictions. The trained equation y is equal to mx plus c after running linear regression. Model training, the process of feeding data to an algorithm so it can learn and become a model. Using a past using past house price data to learn the best fit line. Applications like financial services used for the fraud detection, loan approval automation, and personalized investments recommendations using predictive algorithms. Healthcare helps in disease predictions, treatment suggestion, medical diagnosis, and drug recommendations. Manufacturing enables predictive maintenance, automated production lines, and quality control to improve efficiency and reduce downtime. Commercial and retail analyze customer behavior, forecast market trends, and supports targeted marketing and product personalization. Advantages automates complex tasks by learning patterns from data without explicit manual programming, improves accuracy and decision making through data driven insights and predictions, enables personalized experiences such as recommendations and targeted advertising detects hidden patterns that are difficult for humans to identify, supports real-time processing for applications like fraud detection and autonomous driving. Limitations requires large amounts of high-quality data to work efficiently, so effectively and training models can be computationally expensive and time consuming, difficult to interpret model decisions, especially in deep learning black box models, risk of bias in predictions if training data is biased or unbalanced, needs continuous monitoring and maintenance to remain accurate over time. And again, to revise core characteristics of ML models, like machine learning models, are characterized by their ability to learn patterns from data without explicit programming, improve with experience, automate tasks, find hidden insights, and make predictions or classifications on new data, acting as mapping functions that transform inputs to outputs based on learned relationships. Key traits include data driven learning, dynamic adoption, pattern recognition, predictive power, and generalization to unseen scenarios, all built upon vast datasets and various algorithms. Core characteristics are data driven and experience based, like learn from large datasets, finding pattern and humans might miss, and improve accuracy with more data and feedback. Pattern recognition identify underlying structures and relationships within data, forming the biases for predictions. Predictive and classificatory, like forecast outcomes regression or category is inputs classification. And automated learning reduce human effort by automating complex tasks and decision making. Adaptable and evolving continuously refine performance as new data becomes available, staying relevant in changing environment. Generalization ability to perform well on new unseen data after being trained on historical data. Task versatility applicable across diverse domains like NLP, image recognition, finance, and recommendation systems. So characteristics of ML applications. So here we will see the integrated insights, problem characteristics. How well do you understand this problem? So we can get an insight out of it. And ML absence of insights, ML becomes a black box. Complexity, can you code the rules using a simple deterministic rule-based solutions? Is this a simple problem to solve? How many factors are involved? So this is kind of a complex. The problem is complex. Then solution not easily coded and involves many variables. Accuracy, like what accuracy rate is required. How quickly does your process need to adjust and learn from mistakes? Enable automated learning. Accuracy is based on quality of data and model. Scalability, can a human perform this in a series of repeatable steps? Are you able to scale their efforts? Offer speed and convenience, limited transparency. Data sets, do you have the right data to learn from? Is the data clean? Example, not noisy. The right data is required, requires data transformation and noise reduction. Resources, like do you have resources to maintain your ML solution? Data science, IT, SME. Bottom line, what is the business impact for solving this problem? Works well for solving problems with significant bottom line. So how they work? Model is a function. A model is essentially a mathematical representation, like a line or complex function, mapping inputs, features to outputs, or predictions. Algorithms are used to train fit this function to data, optimizing it to minimize error. Key attributes for good models features like predictive power, strong ability to forecast, data quality, rely on accurate, relevant, and sufficient data, interpretability, how easily humans can understand its decision, import for ethics, feature engineering, creating useful variables from raw data. Like machine learning model exhibits key traits that determine their suitability for tasks, interpretability measures how easily humans understand model decisions. Linear models like logistic regression score high, while neural networks remain black box. Scalability assesses performance on large datasets. Ensemble methods like random forest handle millions of samples efficiently. Overfitting risks occur when models memorize training data. Regularization techniques like dropout mitigation. This is in deep learning. Computational complexity varies. KNN is simple O of n interface but slow on big data versus fast XGBoost for prediction. Types of ML models by learning paradigms. Like ML models classify into four paradigms based on data labeling and feedback. type supervised data requirement labeled key characteristics predicts outputs from input features, high accuracy but label intensive, and example algorithms, logistic regression, SVM, decision tree, random forest, application in CSC, spam detections like unsupervised, unlabeled, discovers patterns, clusters, or flexible for exploratory analysis, like example algorithms are k-means, db-scan, a priori, and applications are like customer segmentation, anomaly detection in IoT, and semi-supervised partial labels like combines label unlabeled data, cost effective for scarce labels, self-training S3VM, and NLP tagging, medical imaging, reinforcement reward signals, learns optimal actions via trial errors, handles sequential decisions, polygradient, policy gradient or PPO, actor critic, and game AI robotic path planning. These are the types of models by learning paradigms. And these are some few suggestions like model selection criteria for your projects, and also hands-on activity assessments like well,